a measuring cylinder. This is a plastic measuring cylinder. We pour solution, 2 molar hydrochloric inside like this. We use it to rinse like that, so that you can remove any substance which was inside, be it water or be it any alkali that could have reacted with this. So we have rinsed. After rinsing, what do? We measure 50 cubic centimeters of this solution, which is 2 molar hydrochloric acid, like this. So once it is very close to the edge, we use a what? A teat pipette. This is either a dropper or a teat pipette. The correct name for this one is a teat pipette. So we suck using the teat pipette, and we make sure we add until just when the lower meniscus is on the line, like that. Until when the lower meniscus is where? On the line, like that. So that is exactly 50 cubic centimeters. The 50 cubic centimeters of 2 molar hydrochloric acid we transfer into the volumetric flask, like this. After transferring, we add distilled water, just in the same way we did with the other one. So once it is at that level, we shake like this. Okay? We shake thoroughly like that. And then we add water up to almost the mark, like this. It's now almost at the mark. So I take some distilled water, which is this, a teat pipette, and I top it up to the mark, like this. So I top it up to the mark like that. So we look at the lower meniscus. It should just stand at the line, and that is where the line is. So it is now done. So we cover with our cork and we shake thoroughly like this. We shake thoroughly so that we can have a uniform solution. The upper solution should give us the same result as the lower solution. So we have shaken thoroughly, and this is the step that most students usually fail. They shake lightly, so that the upper solution is having a lot of water and the lower solution is having less water. So the solution that is having a lot of water is dilute. Therefore, it will give us different results from the lower solution. So if you perform 2 or 3 titrations, we realize that the values you get are different from each other. The burettes are facing you, and the zero mark is at your eye level, so that you can now add solution K, or you place the solution K into the burette. So this is our solution K. We pour it into the burette like this. Once it is full like that, we lower it until it is a zero mark. We can remove this, and then we press until it is at 0. So we look up there until where we have 0. So that is almost 0. That's exactly 0. Lower meniscus to just touch the zero line, or the zero mark. Are we together? So exactly. So we have stood there. That's where our zero has reached. Then we pipette 25 cubic centimeters of solution K. So this is our solution K. We prepared it. Solution N, sorry. So this is our solution N. We can suck. It is very possible using the mouth. But because of diseases, if I suck and then you come and suck, and it was poorly cleaned, what will happen? The disease will be transmitted from one person to another. So, to avoid diseases, what do we use? A pipette filler. So you press the pipette filler like this, and that is effective. So we press the pipette filler like this. You place it inside here, slightly. Some of you place completely. That one will give you a problem when it will be removed. So you just place it slightly. You press first to remove the air, and then you place it slightly like this. After placing slightly, you dip it into solution. Solution what? N. And then you let it suck the solution like that. This one is having a big problem. Have you realized it has changed before time? Yes. Slowly. Look at the way it is moving down. You lower it slowly, like that, until it reaches the mark, which is here. So this mark is exactly 25 ml. 25 ml is the same as 25 cubic centimeters. So we lower it like that. It is at the mark, so we stop it. You press it hard. Then transfer like this. We transfer it like that. So you transfer it like that. Good. So whatever is remaining, you just touch into the solution like this, and you remove. We don't blow, because whatever is remaining here has been catered for when it was being manufactured. Are we together? So we have our solution there. Then we add 2 drops of phenolphthalein indicator. 2. 1, 2, like that. So what do we do?
Shake.
You swirl. This is not shaking. This is swirling. Are we together? So after we have swirled, we place this one inside here. If we feel that we are not comfortable holding it, we are free to adjust this to move up. You are the manager of the experiment. You decide where to perform from. Are we together? So from there now, we perform the first experiment, which is referred to as a trial experiment. So in the trial experiment, I'll just run it until it just changes. So I'll pinch. This is the pinch type of a burette. Pinch type of pipette. So we add like that as we start. It's moving drop by drop as we start, like that. So until when it just changes. You cannot drop by drop like that. You will even get an accurate answer. So there will be no need for us to do it. To continue adding. almost there. So you add a drop, and you see it is still it is completely changed. Good. So we make a reading. If the reading is hidden, what do? You open, you raise it up a little bit, like that, and then you read. If it is not clearly visible, take a white paper like this, so that it can assist you to read. You put by the side like this and read. So this is 13, 21, 22, 23, 24, 25, exactly 13.5. So we read moving down. We don't read moving up. The values increase as you move down? No. Move down. So what do we do to that result? Let us now look at the filling of the table. Now when filling this table, we start from the initial reading. Now the initial reading, you write 0.0, 0.0, and 0.0. All of them are placed 0.0. Is that okay? Yes. Now, the volume that you have got is 13.1. Sorry, 13.5. So that 13.5, you write 13.5 here, 13.5 here, and 13.5 here. Now, to get the volume of the solution used, what do? You subtract. So 13.5 minus 0.0, 13.5. So we have 13.5 there. 13.5 minus 0.0, 13.5 again. And here again, 13.5. If we do like that, we'll get almost all the marks. We have the following marks for this table. The mark for complete table, the decimal mark, the accuracy mark, and the principle of averaging mark. And you look at that. Is this table completely filled? Yes. So you score 1 mark. Have we used the same decimal places in the whole of this? We have. So to get that decimal, you make sure you put this one to be visible. Make sure this decimal is visible. If it is not visible, then this one is going to be 0, 0 instead of 0.0. If this is 13.5 and this point is not visible, then this one is going to be 135. 13.5 not visible, the decimal point, what do you get? You get 135. So decimal point, we have 1 mark. The principles of averaging. Do we have 2 values that can be averaged? Yes. We average values which have a difference of plus or minus 0.2. So if you subtract this, 13.5 minus 13.5, 0. 13.5 minus 13.5, 0. So we have 3 values which can be average, because their difference is within the range of plus or minus 0.5. Are we together? So you have the mark for principles of averaging. Now the accuracy mark will be pegged on the school value. The accuracy mark will be pegged on the school value. So if the teacher got 13.5 and you have 13.6, you'll be having 1 mark. Are you seeing that? If you have 13.4, you'll still be having 1 mark. And how do you get that 1 mark? By titrating until just 1 drop changes the color of the solution from pink to colorless for the case of phenolphthalein indicator. So here, let's assume even we have scored 0. How many marks do you have? We have 3 marks. The mark for complete table, the mark for decimal point, the mark for accuracy, and the mark, sorry, you have missed the mark for accuracy, but you have got the mark for principles of averaging. So what do? You have 3 marks there. Are we together up to that point? Yes. So now, we move to the next question, which is calculate the average volume. Is it? So the average volume will be what? We look for those values which are averageable. And we have said in this case, it is what? That 10.5 and that 10.5 and another 13.5. Divide. The division line should start from this end to the other end, where we have the values written. How many values are these? 1, 2, 3. So you divide by 3. If you press your calculator, you'll get what? 13.5. So, as a good student, do not write any unit in front here. Do not write cubic centimeters. We know it is cubic centimeters. Do not write milliliters. We know it is cubic centimeters. Why am I saying you should not write? The reason is this. You can easily commit yourself wrongly. If you write here centimeters and forget the cube, what is that? 13.5 centimeters. Is that volume or length? That is a unit of measurement of length. If you forget this C, what do you remain with? M. So it is 13.5 meters. It is still a wrong commitment because this is for volume. You might forget that one and have M cubed. That is now another unit of volume, but a very large volume. Are you seeing that? So leave it the way it is, like that. Are we together? Now the next question. Calculate the concentration of solution K in moles per liter. So here is our solution K. Here's our solution K. How did we prepare it? We took 50 cubic centimeters of 2 molar hydrochloric acid. So what was the volume? So volume 1 is equal to what? 50 cubic centimeters. What is molarity 1? Molarity 1 is 2 molar solution. Are you seeing that? Yes. Now we want to calculate the new concentration. So volume 2 is actually the volume of this volumetric flask. What is the volume indicated? 250. So the new volume is 250 cubic centimeters. Are you seeing that? 250 what? Cubic centimeters. So we are being asked, what is the new molarity? That's molarity 2. So how do we usually calculate the new molarity? We use the dilution formula, whereby we say molarity 1 times volume 1 is equals to molarity 2 times volume 2. What do you mean? Molarity 1 is the molarity of the concentrated solution. Volume 1 is the volume of the concentrated solution. Molarity 2 is the molarity of the dilute solution after adding water. It is still water that you are adding. And volume 2 is the new volume after adding water. So let us make molarity 2 the subject of the formula. So we divide by volume 2. We divide by volume 2. So this one and this one go. So we'll have molarity 2 is equals to molarity 1, volume 1, divided by volume 2. So let us substitute. What is molarity 1 there? 2. What is volume 1 there? 50. We divide by volume 2. What's volume 2? 250. So what will you have? 100 you divide by 250. What do you get? 100 divided by 250? 0.4 molar solution. So again, do not commit yourself by writing moles per liter or moles per dm cubed unless you are too sure. But because most of us are not usually too sure, just leave it at 0.4. Whoever has written this will know it is moles per liter. Lastly, the last question. Calculate the number of moles of hydrochloric acid in solution K. So we have one formula for calculating the number of moles that can be used where we have volume. So it says number. Yes? Yes. Concentration is molarity. So number of moles is equals to volume, okay, volume, and that volume is in cubic centimeters times molarity times molarity, okay, and that molarity is usually divided by 1,000. Okay, so what is the volume? The volume is that of the average titer. That is what? 13.5 times molarity. What's the molarity? 0.4. We divide by 1,000. Can somebody press the calculator and give us the answer?
0.0054.
That is 0.0054.